Hello friends, welcome. Friends, you might have seen this press release of Airtel which came out yesterday, 29th July 2024. If you see this, New Delhi. And this is the press release page of Airtel, which says that Airtel reforms its mid-band spectrum to meet the exponential growth of 5G traffic. And it also says that what are those mid-band spectrum? Let's look at this: 1800, 2100 and 2300 megahertz band. And it basically talks about, it says that the pilot on SA and NSA switch has been conducted in Rewari, Chennai, Bhubaneswar, and the results have been very encouraging. This capability of 5G network will enable Airtel to introduce new innovative application service through OpenAI differentiate connectivity service-based architecture. And then it also says, as more customers pivot to our 5G services, we have reformed our mid-band. We have reformed our mid-band spectrum, which was being used for 4G services. With this, we also are ready to launch standalone technology, which means that the Airtel network will be first network in India to run both standalone, non-standalone mode, allowing us to deliver best experience in the market. I don't think that this is correct that they have reformed. They are reforming, because they may not have. It is not possible to reform every bit of spectrum, mid-band spectrum to 5G. So probably it means that, because they are talking about pilot down below, right? So it is, I think that they are in the process of reforming. They probably haven't reformed each and every bit of their spectrum. So what I did, friends, is that I wrote an article in the morning. Just now, actually, not in the morning. I just finished writing this article 1 hour back. And this article, if you read this article actually will capture all the technical nuances and the challenges that Airtel is going to face while reforming its existing mid-band spectrum. That's the whole point about this article. I'm going to briefly go through these headings of this article. You'll see that it talks about understanding the basics, and I'm going to take you through each and everything. And then if you dive down below, you will see that it talks about non-standalone services, that it analyzes the expansion plan of Airtel, and then Airtel's 5G, NSA and SA network. And then it talks about the various scenarios under which 5G, SA and NSA can be used. And also it talks about the challenges and concludes at the end of the article. What I'm going to do, I'm going to place a link of this article in the description. Whoever is interested, he can basically go and deep dive into this article, and he'll get the gist of this video, which I'm going to lay out before you right now. Why I'm doing this video is, some people might find it difficult to understand this article, though this article has been presented in a readable format with as much simplicity as possible without compromising on the details, because when you do things very simple, you tend to lose details, and that makes the things very trivial. I don't want to make things trivial, because this is a serious issue. You can't be making things trivial, and that will confuse the issue significantly. So let's go step by step. First, let's understand what is standalone and what is non-standalone. Let's understand that fundamental, because if people don't understand what is standalone and what is non-standalone, there is no point in discussing all these things. So in 5G, what happens, or any network, what happens is that there is a RAN, which is radio access network, RAN, we call it RAN, radio access network. And then we have the core, right? My pen is, see, I'm not very, very efficient in using my pen, so bear with me. So then we have the core. Now this core, what this core does is, it kind of aggregates all the traffic which emanates out of the RAN, and the RAN is shown here as clouds. So what I've shown here, I have shown a 5G SA network, I have shown a 5G NSA network, and I have shown a 4G simple LTE network. Now, as per the announcement which you saw recently, we I showed you the announcement. It talks about simultaneous existence of all these modes together in the network, right? Simultaneous existence. This is important. This is first of the kind in India, where simultaneous existence of all the modes will be there. Now, one thing you have to understand is that whenever a user registered in a 5G standalone network, then within the combo core, there it will be segregated into two different compartments, which will be 5G core and another will be 4G core. 5G core will register a user which is a standalone 5G user. Very, very important to understand. It is not going to register anything else. 5G standalone user will be registered in the 5G core as a 5G user. Now, an NSA user, which is 5G non-standalone user, will be registered in the core as a 4G user. This is very important to understand. Not as a 5G user, because the 4G core is fundamentally used for serving an NSA 5G non-standalone customer along with their ordinary 4G RAN services. So it is a 4G core services, and that is why you are not able to get all those specific features of 5G, which is network slicing and low latency. So this is one important point of principle which we need to understand. Then we need to also know that any 5G base station which is configured into a 5G mode for a particular block of spectrum, this BTSs can be equipped to operate simultaneously in dual mode. Means it can operate in both standalone mode as well as non-standalone mode simultaneously. This is important. There was another configuration where a 5G base station could also have operated in 4G mode, but that has been abandoned. It has not been very successful because the capacity of the network went down by 20% when you do that. When you do a simultaneous dynamic spectrum sharing, they call it, you do 4G and 5G together, then 20% loss of capacity happens, and therefore it was not very popular. People don't do it, right? So that is the other thing. Then the C is, the third part is 5G services in an SA mode. How it basically would work. Now, whenever you are working a 5G service in SA mode, which is standalone mode, what happens is that the network of 5G network becomes a distinct 5G network like this, which you see that we have the 3500 MHz band operating on the top of the network, and then we have the 1800 MHz band, both downlink and uplink, operating simultaneously with the 3500 5G network. So this is also 5G and this is also 5G down below, right? Now, what is the distinction between a NSA mode and an SA mode? The main distinction between the NSA mode and the SA mode is that when you are operating in an SA mode, then what happens is that the network of, as I told you, it gets registered into a 5G core services. You get all the features of 5G like low latency, network slicing, handset level slicing, etc. But if you have a CA device, which is a carrier aggregation device, then both these bands, 35 and the 1800 MHz band, will operate as if that this is an integrated spectrum. Like you see here, carrier aggregation in 5G devices. So this 3500, which is a TDD spectrum, 100 MHz, this 100 MHz will add with 10 MHz of 1800 MHz spectrum and will create a block of 110 MHz, and the uplink of 1800 MHz spectrum will remain isolated, separate. Now, what is the advantage of doing this? The advantage of doing this is that when you do this, then this whole network acts as an integrated network, and the acknowledgement, the ACK and NAC signal, right, which is basically a handshake signal to register the device into the core, that signal will be available throughout the network when the 3500 MHz band coverage is going to be available. Like typically what happens is that the 3500 MHz coverage, let's say this is the base station, the 3500 MHz coverage will be limited to this. It's not going to go far, right? But the 1800 MHz coverage is going to be a little bit more compared to 1300. Now, there is a slight nuance here. What is coverage? Coverage is from the point of view of UE handset, not from the point of view of base station, because the challenge is there for the handset to reach the base station, not the other way around, because base station typically can transmit at higher power, right? They can transmit at higher power. So when they transmit in higher power, so you may continue to get the coverage of the base station of 3500 megahertz band, but you won't be able to communicate back to the base station in the same block of spectrum. For that you need 1800 megahertz band, which will have a better coverage in the uplink, because this band has a lower frequency and the better propagation characteristics. So in the front, that is in the downlink, because in 3500 plus 1800 in the downlink, this whole spectrum will act as an integrated spectrum. So your ACNAC, for ACNAC you can use both the spectrum, the 1800 as well as a 3500 for signaling purpose. So your network coverage actually expands because both the bands are joined together. If you are going to use these bands in isolation, in separate blocks, like 3500 you use separately and 1800 megahertz band you use separately, then what happens is that the coverage of that block of spectrum will be determined by the ability of the handset to reach the particular block of reach the base station using the same block of spectrum, the same frequency. You can't leverage the lower frequency band if you are independently using these block of spectrum separately. And that is why carrier aggregation is a very important feature, without which standalone mode definitely will become dysfunctional in mid-frequency band. In the low frequency band the picture is slightly different, we are going to discuss it, but in the mid-frequency band it will become dysfunctional. Why? Because what will happen is that, let's say if you are at the edge of the network, let's say if you are at the edge of the network base station is here. Let me just draw a base station. This is a base station, and the base station has got a coverage which kind of goes up to this, and the 3500 megahertz coverage only goes up to this, and you are at the edge of the network 1800. Here 1800 coverage will be available. So what will happen if you are a non-CA handset, then this block of spectrum will be completely ignored and you will be locked into the 1800 megahertz band. And once you get locked into the 1800 megahertz band, then both the downlink as well as the uplink will be limited by this 10 megahertz spectrum. So your capacity or your ability to download and upload data is going to be worse than an NSA mode. You can imagine this. So CA, without CA, standalone 5G is worse than NSA. That is what I want to tell you. And we need to have CA before we implement even a mid-band 5G SA network, without which it is going to be virtually useless, because 1800 megahertz, once it acts in isolation compared with the 1300 megahertz band, the network upload and download speeds are going to decrease significantly. However, if you are on the 3500 megahertz band, you will not be able to get access to the 1800 megahertz band. Then you are dependent on the 3500 megahertz band for upload and download. So you will be fine, reasonably fine. But you will never be able to get the support of the 1800 megahertz band as soon as you get out of the network coverage. So that is the point which I wanted to discuss here. You see here, the 5G in SA mode with device working with CA. So this is what the 5G SA mode device working with CA, where you can actually use the download. For download you can use both 3500 and 1800, and upload you can use 1800 alone. So imagine the kind of benefit that you get. Now what happens is that 5G services in non-NSA mode. Now in non-NSA mode, what is the way you will be working? You will be locked into a 4G carrier. So whenever you are working in a non-NSA mode, as far as 5G is concerned, the anchor carrier always has to be 4G. This is very, very important to understand. It can't be 5G. It has to be 4G. And therefore, what typically happens is that the lowest frequency, let's say 900 megahertz or 1800 megahertz, whatever is available, is chosen as the anchor 4G carrier for NSA 5G. Now, let's say if you have two different block of spectrum, let's say if you have the 1800 megahertz band and the 3500 megahertz band, typically in a scenario like this, let me just go to my slide and let's talk about the scenario where we are. This is the scenario. Let's say you have 3500 and we have got 1800 megahertz band, right? Now, what happens in case of a NSA mode, what will happen, right? If you have the anchor carrier, so let's look at the NSA mode like this, because I've made 5G there. So let's look at this block of spectrum, this diagram. So let's say if your anchor is 4G and your 5G band is 3500 megahertz band, which is on top. Look at this. This is the current scenario where you have 3500 operating 5G and you have got all the other layers operating in 4G. So you can choose an anchor layer which is the 900 or the 800 megahertz band. Now the problem is that, as I told you, the coverage of the network is not determined by the base station transmitting to the handset. It is the other way around, because handset has got poor power transmission capability. So what happens is that the 3500 coverage, which I've shown as constraint compared to the 700, 800 and all other mid-band spectrum, this will be a little bit stretched when in the downlink direction, because the base station of 3500 megahertz band will have high power. So it will be stretched in the downlink direction. So normally people will say, oh, I already have the downlink from 3500 megahertz band. I can use the uplink from the 900 or the 1800 megahertz band. I will have a very seamless coverage. That you can only do in SA. But in NSA, you can't do it. Let me tell you why. The reason you can't do it is the acknowledgement signals, the signals which are basically getting exchanged to register the device in the 4G core, in the combo core, the 4G part of the core. That signaling only happens within the 5G band. It can't happen through the 4G spectrum band. So what happens is that though the 4G coverage is stretched, you won't be able to reach the 5G base station, because you are not allowed to use this for signaling purpose. You have to use the 3500 megahertz spectrum for signaling purpose, and therefore if you are out of the coverage area, then this block of spectrum will not be available at all. You will be pushed back into 4G. That's the basic problem with NSA mode, which many people do not have a clear understanding. It is not about integration of the 5G and the 4G network together. It is about registering into the core, which I explained to you, right? That you have to register and you have to basically exchange signaling. The device has to exchange signaling, and that happens only within the 5G band. For that, you cannot use the 4G band. You can only do when you have carrier aggregation, but carrier aggregation across technology is not possible. You can't carrier aggregate 4G and 5G. You can only carrier aggregate 5G with 5G, 4G with 5G. Carrier aggregation across technology is not possible. So that is a basic problem with NSA mode. The NSA mode has got the fundamental issue with this. So probably we've understood what I am talking about. Now let's go further down. So here I have already explained all this which I told you. Now let's talk about the Airtel expansion plan. So what did we say? Airtel is working to expand their mid-band spectrum. So all this mid-band spectrum, not this spectrum. This is the low frequency spectrum which they cannot reform unless they have an equivalent low frequency spectrum to park their 4G subscriber. This is going to be extremely difficult for Airtel to implement. They can, however, do refarming of their mid-band spectrum, that is the 1800 or the 2100 or the 2300 megahertz spectrum, in order to as a network theoretically possible. But there are going to be certain issues and challenges which we are going to talk about. Let's say that Airtel is doing this. This is the case one. And what they do is, because they have to do it incrementally, so they already have an anchor spectrum of 3500 megahertz running in 5G. They will basically convert their 1800 megahertz band, which is more than 15 megahertz in some places. Let's say they choose 10 megahertz to convert their 1800 megahertz to 5G, and they combine these two bands. They create a standalone network, right? They can very easily do that, but they will also have a non-standalone network running in parallel, right? Where the same, as I told you, both the spectrum, both the BTSs can work in standalone and non-standalone. There is no problem. So this will work in non-standalone also. Then we have 4G, with which they have not reformed. Then we have got 2100, they have not reformed. The 1800 megahertz block of 4G will reduce by the amount that they extracted for 5G reforming. So earlier it was 16.1 on an average pan-India. Now it will become 6.10 on an average pan-India. and then we have got the 4G down below in 900 megahertz spectrum. Now what happens is that if Airtel does 5G handset without carrier aggregation, which I have already explained to you, what will happen? Then what happens is that these two blocks of spectrum will be treated separately by the handset, right? So if the handset is going to be near the base station, it is going to use 3500 megahertz band. So you'll have uplink, downlink both running in 3500 megahertz band, no problem. But as soon as you come out of the coverage, you are basically going to get locked into the 1800 megahertz band, and your download and upload speed is going to become minuscule, because 10 megahertz of 1800 megahertz band 5G is be better running in NSA mode. So what they have to do now, either they have to push the handset into NSA mode. As soon as they fall back to 1800 megahertz band, which is a non-CA handset, what is the point then? Then there will be a barrage of signaling, which of this kind of fluctuation back and forth between NSA and SA is going to create a barrage of signaling traffic within the network, will make the network management very difficult. And that is why, if you look at China, China has abandoned their NSA mode and they have moved only to SA mode. They have only one single mode in the network, right? But if you continue in SA mode, then your quality of 5G is going to be very bad. So what they can do is they have to now, because this handset with the capability to do carrier aggregation across bands 1800 and 3500 may not have been seeded in the market so much. So they have to wait for the handset with carrier aggregation capability between 3500 and 1800 megahertz to be available, so that people can leverage this SA mode, which can operate with 3500 and 1800 megahertz, can use this block of spectrum as if that it is one, which I have already explained earlier, right, in my video. Now let's look at the handset with, so I explained to you handset without carrier aggregation, the throughput will decrease. Handset with carrier aggregation, there will be a significant improvement, because both these blocks of spectrum, which I explained earlier, this will be treated as one. So you will have a very good quality of experience till the time your 1800 megahertz 5G coverage extends. So as long as you will have an 1800 megahertz 5G coverage, you will be able to receive the downlink of 3500, because the power of downlink of 3500 will be better. So handset will be able to lock into the signal, because they will be able to communicate back to the base station using 1800 megahertz band. So quality of the network will be better. But as soon as your 1800 megahertz spectrum or the coverage drops, then they will have to go directly into a pure 4G mode. They will have to latch on to the 900 megahertz spectrum. So there will have to be a handoff happening immediately from their standalone 5G to a pure LTE network, with latching on from the, you have to do re-registration from the 5G core to the 4G core, which will enhance their signaling traffic. So this is why I have mentioned all these challenges. So this challenge part is very important. Whoever is reading this article should read this particular portion after having understood the explanation. So what I am saying the primary concern is therefore reduction in 4G capacity, which results from reallocating substantial portion of the mid-band spectrum to 5G. So what you have done here, if you look at this block of spectrum, what you have done from the layer which is below, which is 1800 megahertz spectrum, which was earlier 16.10 megahertz on an average pan-India, you have extracted this 1800 megahertz spectrum, 10 megahertz, and allocated for standalone 5G. So the normal 4G devices, which are currently operating in the network, which have got carrier aggregation capability and they are mature devices, immediately will lose this block of spectrum, and this pool of spectrum 10 megahertz will get absent from the 4G pool, which will limit their capacity. So unless and until there are devices which are available in corresponding devices with CA capability of 5G, which is able to leverage this capacity, the 4G network will be constrained. Now one more thing which I have not written in this article, and I am going to let it out orally before you, is that this TDD spectrum, which is 3500 and 2300, actually is a big problem. Let me explain to you why. What happens is, during winter there is some kind of interference which actually travels through a atmospheric condition called waveguide. So what happens is that, let's say if you have a network here of 2300, and let's say if you are in Himachal Pradesh or any other state, let's say Delhi. Now, if you have a network in MP or any other state, what happens is that both the networks have to be isolated from each other. But what happens in new winter, because there is a waveguide effect, right, in the atmosphere, signals will emanate out of the 2300 or the 3500 megahertz spectrum and is going to go and interfere with the same band in some other jurisdiction and will cause a huge problem. Now, when signals travel such length, then what happens is that the bits will get phase shifted. And you cannot manage them with cyclic prefix, because as the distance increases in kilometers, the time delay between the bits becomes so high that you cannot manage it with cyclic prefix, and therefore your efficiency of the network is pulled down. The 4G network and the 5G network will pull down, and therefore you cannot tolerate any inefficiencies in the network by reallocating spectrum in a situation which can't be leveraged efficiently. You got it? So that is the problem as far as Airtel's main issue is concerned, right? As far as the challenge is concerned. The other important challenge is that voice. Now, what is 5G voice? The 5G voice is voice which is running purely on 5G SA network. Currently, even Reliance to some extent, they are using 4G to run voice, and they are still testing their SA voice capability, and they will finally move their voice to standalone 5G from 4G. So whoever is having a standalone 5G handset will be able to use the standalone 5G for voice. Now, if you have a mid-band spectrum, let's say if you have a mid-band spectrum like this, with no capability to anchor the 5G voice at a low frequency band layer, then what will happen is that your 5G voice capability will be only limited to 3500 and 1800, and it will immediately vanish. Means you do not have a similar network as 4G where with low frequency band where indoor penetration of voice can happen. So your 5G NR voice capability without an SA network with an anchor low frequency spectrum will be poorer than an operator who has a SA network with a low anchor frequency. You will not be able to run your 5G voice efficiently. And 5G voice, by the way, is a very important service, more important than even carrier slicing or U-based slicing, because the quality of 5G voice will improve and the 4G will be congested. So when users are going to be in 5G voice, they will definitely experience a better performance compared to what 4G voice, which is highly congested right today. Now, the last important challenge would be when you have a combined network. What happens is that in a combined network, you are continuously switching between SA and a non-SA, right? Because you see, moving. So here I mentioned there will be a very important issue, which is SA and NSA network creates a complex barrage of signaling traffic because of the need to switch between two different networks under different conditions, and therefore it kind of creates a lot of complexity in the network, and therefore operators typically would like to keep both the networks separate, not interwork with each other or integrate with each other, because the network will become very, very complex. So this is what I finally conclude in my article. If you see my article, what I'm saying is that the strategy of implementing SA in the mid-band anchored with CA capability across 5G, without CA capability of 5G will remain a suboptimal approach, right? So you need to have CA. Second is that moreover, using mid-band anchor for 5G is a problematic for supporting NR voice, which otherwise would improve the voice experience of the current user, which I have already explained. And operating a network in combination with SA and NSA mode complicates the architecture due to frequent transition between 5G core and 4G core for user registration, leading to significant increase in signaling traffic. So these are the things. So I believe that Airtel will have to do incremental refarming of their 4G spectrum depending upon the ecosystem of CA devices. As the CA devices ecosystem grow, then it will make a lot of sense. However, they cannot ignore sub-gigahertz 5G spectrum. I am telling you again and again, I have been telling so many times that 5G sub-gigahertz spectrum is going to be extremely essential to create a robust standalone network which will be isolated from their non-standalone network, which is going to result in a huge confusion and signaling traffic, and therefore that is why China has moved into a SA network rather than having a mix and match of both. So friends, I hope that you probably understood this. It has become a little bit longer than what I expected, but I hope that I have done justice to this video to able to give you a very, very unbiased, factual analysis of the current situation, which is going to be in the interest of a larger interest of everybody, consumers, operators, and everybody, because everybody will get benefited in the end of the day. So thank you for your time. I hope that you like this video, and I'll come back with a new video next time. Thank you very much.